Hi everyone, thanks for coming out. Thanks for coming to Render. It is great to be here. My talk is the bleeding edge of web development. This is a topic I'm really excited about, and I'm pumped to be out here presenting it to you guys. All right, and with that, we are going to start our story with a really quick but painless and friendly history of web development. In the beginning, we had a user on a browser. They'd enter a URL somewhere they wanted to go. That request would hit a web server. Web server would probably request some data from a relational database, send back the data to the web server. Web server would kick back some HTML, JavaScript, and CSS. And life was simple, but not easy. That single web server sitting in the middle was a pretty bad point of failure. It was very easy for it to get overloaded on traffic spikes. As your user base started to grow, you have too many users, that web server could start to fail pretty easily. Scaling is hard. So it's just a 25-minute talk, so we're going to skip quite a few things on this history of web development, web scaling. We're going to skip over caching, scaling to multiple servers, load balancers, reverse proxies, all that good stuff. I'm not an SRE. It would be a fun talk to give, but it's going to have to come from someone else at some other time. I do want to briefly call out horizontal scaling. I just want to define it for you. It means going from one server to multiple to kind of spread that load out because it's going to be pretty relevant for this talk. So horizontal scaling, this is the before, and this is what the after looks like. So we have some mechanism to direct some users to one web server and some users to the other to sort of spread that load out. And of course, it's not just two, it's two or more servers. All right, let's get back to our talk. Scaling is hard. Where to? How do we solve this? We're going to skip over all that long history of web scaling, and we're going to YOLO all the way to AWS. Amazon Web Services. It's a suite of over 100 services. It does anything and everything you could possibly imagine. For our purposes, though, we're going to focus on AWS Lambda. Lambda functions are independent pieces of code or functions that you run on demand. You define them, you send them over to Amazon, and now they exist, and you call them whenever you want. And Amazon does all the dirty work of spinning up whatever containers are needed to handle that Lambda request, send back the result, and so on. As the number of users increases and you get traffic spikes, Amazon is good enough to spin up as many containers as you need so that you don't have to worry about that single web server failing like before. So Lambda was originally pitched as sort of compute on demand. If you have some task that you need run on demand, that's what Lambda was pitched for. So my favorite example of an ideal, perfect use case for Lambda is like user picture upload. Like if you have a web application and your user uploads a new profile pic, you need to take that pic and crop it and resize it and then stick it in an S3 bucket, and we can send that to a Lambda to do. The Lambda will crop and resize our picture, stick it in an S3 bucket, and send back the URL to that bucket. It didn't take long, though, for some creative web developers to realize that if we can use a Lambda function to upload and resize a picture, we can use a Lambda function as a web server. Because a web server is nothing more than taking a request in and sending back some HTML, CSS, and JavaScript. And there's no reason why a Lambda can't do that. So if we think about what that might look like, we go from something like this to something like this. So now instead of that single web server in the middle, AWS spins up as many instances of our Lambda that we need. And you can reuse the same Lambda for more than one user. Don't think it's like one request per Lambda. After the Lambda is done handling a web request, it doesn't die immediately. It stays warm for a bit and able to fulfill the next request that might come in. And we're going to talk all about cold starts in a bit. So this is interesting, and you might be intrigued, and you might say, okay, I've got a web application. I want to run it in this cool way on AWS Lambda functions, so I can get that free scaling, that free horizontal scaling. Setting that up has got to be really hard, right? It turns out it's really easy, and it's easier than anything that came before, and the reason is because of this amazing company called Vercel. I don't work for Vercel. They're not paying me to tell you how great they are. If they ever want to, I'd be happy to take their money. But for now, I'm just telling you about them because I love them and I love their products. Vercel is the creator and maintainer of the Next.js framework, which a lot of you have probably used. And they're also the maintainer, not creator though, of SvelteKit. They employ a few of the SvelteKit maintainers, including the original creator, Rich Harris. But most importantly, Vercel has a hosting platform that's second to none. Even if you're not using Next or SvelteKit, you can still host your web application on Vercel. It's a joy to use, and when you do use it, by default, you get that. And it's like that Office meme, corporate wants you to tell the difference between this picture and the thing. It's the same picture. This is what Vercel does for you. It sets up your web application to run off of AWS Lambda functions. So life is good. You have to do a few things. If you're running like passport.js authentication middleware in memory, that's not going to work in a serverless world. So you'll need to use some sort of grown-up solution like Next Auth or Clerk, which is a new entrant into the authentication space. But otherwise, life is good. I'm 5 minutes into a 25-minute talk, so you probably sense that maybe we haven't solved everything and that this isn't a panacea. What's the catch? Cold starts. So I told you before how AWS will spin up the containers that you need for those Lambda functions whenever you need them. That spinning up is not free, and it's not even cheap. It's not egregiously expensive, but it's not free either. It's a noticeable delay when you have a web app running on Vercel. That first hit, you can tell it's a little bit sluggish. We're talking a few hundred milliseconds, which is not great. I will say that having users does help. There's an old joke going around. The solution to cold starts is having users, because as you have more users consistently using your web application, those Lambda functions will stay warm. The Lambda function handled your last user, and now the next one comes in, and that Lambda is still warm and waiting and ready. It still won't solve all your problems. You still have traffic spikes. You still have periods of time when fewer users are using it. It's not a perfect solution. So what we really want, ideally, is we want this conceptually, but instead of all those lambdas, we'd like something else that doesn't have that latency. Pause for effect. Cloudflare workers. And this is where the title of the talk came from. Cloudflare workers, otherwise known as edge workers. So this is kind of a not fun slide to do, but I have to do it. It turns out the word edge means more than one thing. Edge originally meant geographically distributed. So like if you think about Cloudflare, they're most known for their CDNs. When you request an asset from a CDN, the CDN is going to be smart enough to direct your user to the closest edge node that happens to be closest to them. Edge used to mean geographically distributed. And these Cloudflare workers are geographically distributed, so it kind of fits. But you can also pin your Cloudflare worker to a specific part of the world. And we're going to talk about that in a bit. But you wind up with this contradiction where you have an edge worker that only exists in one part of the world. It's a contradiction. Some people are mad about it. It's a whole thing. This is Dax. He's the author of the SST framework, which is really cool. I suggest you check him out on Twitter. But to get our talk back on the rails here, we're going to talk about edge workers a lot. And by edge worker, I'm going to mean Cloudflare workers. So what are Cloudflare workers? First of all, they're low latency, no cold start. So we haven't even started yet, and we've fixed the cold start problem. So we're off to a good start. They are low latency, that's what I just said. They're geographically distributed if you want them to be. They can run anywhere in the world, or you can pin them to a specific part of the world, and we'll talk about why you might want to do that. And they're fast. They run on V8 isolates. They do not run on Node. I'll say that one more time. They don't run on Node, which is why they're fast, but it also comes with a little bit of baggage that we're going to talk about. Okay, so you're intrigued. You've got your web app. It's running on these AWS Lambdas, but you want to get rid of that cold start. So you're like, okay, edge worker, I'm in. How do I do that? Well, you're not going to believe this, but the same Vercel also will be happy to render your web app on these edge workers. It's baked right into their hosting platform that I just told you about. You just add a little bit of configuration to your web app, and just like that, it's running as an edge worker. No cold start, nice and fast, and life is good. So what are the downsides? I told you they run on V8 isolates and not Node, which is sort of a two-edged sword. It's what kills those cold starts for us, but we're not running in Node anymore. And so that means we don't have a lot of the low-level utilities that you might be dependent on in Node. So some things are going to stop working. People are working hard to bridge that gap. Things like buffer are getting added in, but there's still things that are not going to work. So about 15 minutes in, we're still not done with the talk. What's the catch this time? Database connections. So you're not going to run much of a web application without some sort of data access. And it turns out, no matter what database you're using, the node drivers that you're using to connect to it will almost certainly not run in an edge worker because they're going to be dependent on some low-level utilities to get that direct TCP connection to your database. And so they're just not going to work in an edge worker. But the problem actually is deeper than that. And so before you just run back to AWS and you say, I'll live with the cold starts, I'd rather have a connection to my database, this was actually always a bad idea in a way. So let's zoom out a little and just remove the users, and let's just focus on this. If you were connecting directly to your database using node drivers on this model, that's already really bad. And the reason might not be why you think. It's the connections themselves. So when you connect directly to your MySQL or Postgres database, it actually takes quite a few moments to establish that connection, and it's a noticeable delay. And also, databases have a very hard limit on the number of connections that they can have going at once, and the limit's a lot lower than you might like, especially if you're deploying a web app at scale. So running our web apps on serverless functions is great for auto-scaling. It solves that problem for us, but it adds a little bit of complication for when we want to start reading data. And the reason is because creating a hard connection to our database on every Lambda function or Cloudflare worker that gets spun up is going to be slow, and that's going to add to the cold start time if we're on Lambda. It just won't work at all in Edge. And even if it did work in Edge, it's always going to be dangerous because you might hit that limit and your database will just stop accepting new connections and your web app is just going to error out. And I actually have a story about that from my first ever paid dev job. I didn't know it at the time, and I may or may not have brought down a production system. Anyway, so how do we cut this Gordian knot? How do we fix this? It turns out that databases have HTTP APIs now, or at least a lot of them do. All the big ones, the ones that you're already using probably do, which means you don't need to set up that direct TCP connection to your database at all. You can just send an HTTP request to an endpoint with some credentials, and you can query your data, or you can update, insert, or delete your data using the same mechanism. And what's even cooler is V8 isolates ship with their own native fetch function. V8 isolates, if I didn't say it before, that's sort of the shell that Google Chrome runs on. Except you take that shell, and now it can exist in the cloud as an edge worker or as a Cloudflare worker. And so they have a lot of those same browser APIs like Fetch. So depending on the version of Node you're using this might even be easier than Node. And there's tons of options here. If you're a Postgres fan, you probably already know about Postgres. You can turn your Postgres database into a RESTful API. If you're more into NoSQL or document databases, MongoDB has this thing called Atlas. It's their data platform. If you're already on it, you can press a button, and poof, you have an HTTP API connected right to your Mongo database. And I've saved the absolute best for last. PlanetScale is an absolutely amazing company. It's MySQL hosting. They are incredibly fast. They have an HTTP API, which is extremely fast. And again, they're not paying me to say that, but I will happily take their money. Mr. Lambert, call me. Anyway, so let's say you've deployed your web app on the edge. You've got a nice HTTP-ready database, so everything is working and everything is good. There's one more important optimization step that you should not miss, and that is to make sure you're pinning that edge worker to where your data are. You want to avoid that latency. So let's say that you have your data hosted in US East 1, which is Virginia, United States. That's where your database is. That's where your MySQL box is. You went into PlanetScale. They asked you what region. You said US East 1, because why not? And now let's say some user in Singapore hits your web app. You do not want that user to be hitting an edge worker in Singapore and requesting data in Virginia. And let's look at why. This is what it would look like, and you might think that that's not so bad. You might think, well, my data are in Singapore, or excuse me, my data are in Virginia, so they're going to have to wind up in Virginia either way. Might as well hit the Singapore cloud function. What's the difference? Well, the problem is this picture is a bit of a lie. This is what reality usually looks like for most web applications. We don't need just a single request for data. There's usually going to be more than one, and occasionally they'll run in serial. We don't want waterfall requests, but life is messy sometimes, and sometimes that's just the way it works out. And this is just going to be a nightmare. You don't want those multiple round trips going from your edge worker in Singapore all the way to your data in Virginia. So instead, we want it to look more like this. Even if the user's in Singapore, we want them to always be hitting an edge worker in Virginia, where our data are. And that way, those requests for data, however many they are going to be very low latency, very, very fast. So how do we pin our edge worker to a specific region? I showed you some next.js code before. I will show you some SvelteKit code now. Pretty simple. You specify the runtime, and now there's another entry if you want to specify the region. It turns out that in Vercel's mind, US East 1 is called IAD1. I don't know why they did that, but they did. So if you want to pin to US East 1, that's what it looks like. If you're using Next, it will look similar. Okay, no more Scumbag Steve memes. We're good. Like, life really is good. We've solved the database. Our web app is running. But occasionally, you might still need to use some stuff that's going to require Node. There's a few examples that come to mind from my own experience. Let's say you have an API endpoint that is being used by mobile clients, and as a result, needs to use some Firebase authentication. The Firebase SDKs are not compatible with edge workers. Or I gave you that famous, that favorite example of a Lambda function for resizing profile pics. Maybe you're using the Sharp image processing library, which is outstanding. Last I checked, it was not compatible with edge workers, and I imagine it probably will never be, based on just what it has to do. All's not lost, though. Vercel is more than happy to let you mix and match. You can have most or even all of your web pages, web page paths, and API routes on Edge, and you can just carve out a few exceptions here and there if you need a few API routes to run on Lambda in Node. You just configure it. So we saw runtime setting to Edge or experimental Edge, depending on the version. Just toggle it over to Node.js for whatever those API routes are that need Node stuff, like Sharp or Firebase. And then when Vercel pushes your web app out on its hosting platform, everything will be set up how you need. So those few API endpoints that need Firebase, they'll occasionally have a cold start. User might have to wait an extra 100 milliseconds to resize their profile pic. They probably won't rage quit your web app for that reason alone. You'll probably be fine, especially if you have users. Okay, if any folks from Vercel are watching this, they might be disappointed that I relegated their big middleware stuff to a footnote, but I covered the parts of edge workers that I find most exciting. But it turns out you can use these things for a lot of other things. And if you're using Vercel, they have this really neat feature called middleware. And middleware are functions that run before every web request. Like you know what middleware is. It means exactly what you think it means. But it's defined inside of Vercel's hosting. And you can do some really neat things with it. Of course, you can do redirects and rewrites. You can modify the headers. But some of the real use cases for this are if you have like A/B testing going on, and you want to put some users in the A and some users in the B, you can hold that configuration in edge-based middleware. And since the middleware runs on edge workers, they are very, very fast. And these actually are geographically distributed. So if your user is in Singapore, you absolutely want them hitting the Singapore cloud worker, reading in the configuration, figuring out whether that user is on the A or the B, and then processing it on and letting it hit the real web app in Virginia, requesting the data, and so on. And what's really neat is Vercel has a whole host of add-on services that work with middleware to enable you to do these sorts of things. Some of them are kind of new. They just shipped a key value storage. They've got Postgres existing on the edge. They've got their own large file storage. They have a whole host of products that go right along with this middleware to enable you to do all sorts of interesting use cases. Check out their docs. They have a ton. It will spell out all the use cases and all the cool things that you can do with these various offerings. But that's about it. Thank you all so much for listening. It has been a lot of fun talking to you, and I'm Adam. Thank you.